Hello everyone, yes, I'm going to give you a brief summing up of my PhD work on the Middle Devonian of northern Spain. I've done a big survey of its palynomorph assemblage, and at first glance it looks fairly ordinary. There's lots of Middle Devonian forms in here. It's really well preserved actually. I've got a nice mix of land-derived spores, marine acritarchs, chitinozoans, there's some skelecodonts mixed in there. But when you look at it rather more closely, you can see that essentially it's really weird. There's species here persisting for longer than they do elsewhere in the world. There's species appearing earlier than elsewhere in the world. And there's various other types that you find in practically every other Middle Devonian assemblage except this one. It all points to this being a significantly endemic assemblage. And this is supported by the fact that Iberia was an isolated island in the Middle Devonian. It had just broken off northern Gondwana and was drifting in a sort of a large archipelago with bits of France and some of the Balkan states and things like that. But this is the first time we've got evidence that this isolation actually affected its flora and fauna. It's clear that certainly the land plant spores weren't able to disperse to this new land, and even the marine acritarchs had a job on as well. There's lots of very well-known acritarchs that don't appear here, and I've got 20,000 of these things. If they were here, I'd have found them. So what can we do with this more than just say it's weird? Well, we can hopefully date the rock it comes from quite accurately. So this is a rough layout of the strata that are found in the three provinces I've looked at. It roughly alternates between sandstone and limestone deposition. I've looked at this sandstone deposit in the Middle Devonian from the lower Iphelian into the lower Juvetian. If we zoom in on that and have a look at the biozonation schemes for it, we can get a better handle on it. So we've got the conodont scheme and the land-derived spore scheme. The conodont one is much better controlled, but unfortunately you don't get conodonts in sandstones. It's the wrong sort of lithology to preserve them, so you don't get them out of the formation I've looked at. But you do get them from the limestones above and below. And so we're able to bracket the age of this formation very accurately. So other workers have found conodonts like this in the Santa Lucia and the Candas formations that enable us to give an age for the Naranco and Huergas of this bracket. The base of it is about 391 to about 392 million years old, and the top of it is about 386 to 387 million years old. So we've already got a really well age-constrained interval. This is rare for a Devonian sandstone. It's one of the best controlled sandstone deposits outside of France, actually, where you've got a lot of conodonts interbedded with their sands. So if we then add in what I've got, this is Geminospora lemurata. This is a very important spore associated with early progymnosperms, and it has a very, very well-defined first appearance datum that's been known around the world, and it first appears in the lowermost Juvetian, just here. Now, I find this spore throughout the top half of the formation I've looked at. That's the only bit that's got palynomorphs in it. The bottom half of it is just a massive sand with no real fossil deposits in it. So what that tells us is that the top half of the formation, which is a good 100-150 metres of sediment, was deposited in this really, really short interval. This is 1.5 million years tops. So this is really rapid sedimentation, all taking place just after a major extinction event called the Kachak. This has been associated with an increasingly monsoonal climate. That's a hypothesis for its origin. It's usually associated with benthic anoxia, owing to an influx of fresh water. But we know that this stuff in Spain is a near-shore habitat. I don't think that the water's deep enough to sustain a strong anoxia. So all that monsoonal input is just going to dump a huge thickness of sediment really, really quickly. And I think that's all we're seeing here. And hopefully this should be a good marker for the Kachak event in other nearshore assemblages around the world. With that, I'll thank you all for listening.